Welcome back, and this video is all about geometric series, which is the sum of a geometric sequence. Quite different to an arithmetic sequence. Watch my other videos if you want to see those. But this one we're going to go through two formulae. One where we have to sum a finite geometric series, so we'll be given a series of terms that we need to sum together. And the formula on the right is to do with when we sum the entire series together. So therefore then the geometric series will converge to a value and we'll be able to sum all of the terms together. Let's dive in. Okay, so here are the 5 questions that we're going to go through. Questions 1 to 4 will involve the formula here up at the top right. We're going to be summing a series of values together, and we call this a finite geometric series. Question 5, however, we will have a converging series, and therefore we can find the sum to infinity. So we'll be summing the entire series up and seeing what value we get on that infinite geometric series.
It's a bold strategy, Cotton. Let's see if it pays off for him.
Okay, so just expanding a little bit more on those two formulae, let's just consider we had a sequence that went 2, 4, 8, 16, 32, and we can see here that the common ratio between the terms is 2. We can do that by taking one term and dividing it by the previous term, and we see that we get 4 divided by 2, which is 2, and that is what we call our R value. Okay, and we can see that the first term of the sequence is in fact 2. So therefore we have enough things here present to be able to plug into the formula. So if we say that the sum of, let's just sum the first 5 terms that we've got here. The sum of the first 5 terms would be the sum of these 5 terms here. Okay, and in order to do that we can use this formula. So the first term would be 2. So 2, open brackets, 1 minus, and now the R value, remember, is our common ratio, so that would be 2 to the power of 5, close brackets, and then we have all this all over 1 minus 2, so which is going to be negative 1. So we can just plug all of this into our calculator, and we will get the sum of a finite geometric series. So in other words, we're summing only 5 terms of this, and if I put that into my calculator now, I get 62, and that is how we use the formula on the left hand side. Okay, the one on the right hand side is when we have to sum an infinite geometric series. So let's consider something similar where we have 8, 4, 2, 1, and then 0.5, and the next one will be 0.25. We can see that the common ratio of this sequence is actually a half. For the same reason, we can take a term of the sequence and divide it by the previous one. We get 4 over 8, which is actually a half. So this is our R value, okay? But we can see that the sequence is actually converging. So as we move on, as we times by a half every time, seeing that this value is getting smaller and smaller, and it eventually converge towards 0 if we went all the way to infinity. So when this happens, we can use the formula at the top here. So we're going to say the sum to infinity of this sequence would be, this geometric sequence would be the first term, which is 8 over 1 minus R, which is a half. So it'd be 8 over a half, therefore we're going to get 16. So this series would converge all the way to 16, and that would be the sum of that particular geometric sequence. Okay, question 1. Find the sum of the following to 12 terms. So the sequence goes U1, U2, U3, and we can see straight away from the question that that would be 2, 6, and 18. And they're just simply asking us to sum them together in the question, but all the way up to 12 terms. So that is n is equal to 12. So if we go ahead and use the formula on the right hand side here, we've got the sum of 12 terms is equal to a, which is the first term, so that's going to be 2. Then we've got 1 minus r. Now the common ratio between the two would be, well, you can just take u2 and divide it by u1, and therefore you have 6 over 2, which would be equal to 3. So the common ratio between these terms is 3. So we're multiplying by 3 every time. So we're going to put that into our formula now. So that would be 3 to the power of n, and remember n is 12, close brackets, and this is all over 1 minus r. So that would be 1 minus 3. Now I'm just going to pop all that into my calculator, and I get 531,440, and that's the end of question 1. Question 2, we've got another geometric sequence, but it has a first term 5, so let's just write that down. u1 is equal to 5, and a common ratio 2, so that's also some information that we need. That's r2. The sum of the first n terms of the sequence is 635, right? So that's Sn. We don't know how many terms that is, but we know that the sum's going to come to 635. Now we can use all this information. Let's plug in what we know into this formula. So Sn, so let's write that down, is equal to A, which is the first term, which is 5, 1 minus 2 to the n, close brackets, over 1 minus 2, right? Remember, they've given us Sn in the question, so that's 635. And we need to now know what value of n do we get to such that the sum is equal to 635. So what we can do here is we can do a little bit of rearranging. So we've got, first of all, this is minus 1. And we can times both sides by minus 1. So we're going to get negative 635 is equal to 5, open brackets, 1 minus 2 to the n. And now we're going to divide by 5 on both sides, giving us negative 127 is equal to 1 minus 2 to the n. Going to subtract 1 from both sides, so negative 128 is negative 2 to the n, and we just times both sides by minus 1 again, so we get 128 is equal to 2 to the n. Now there's a few ways you can do this. One is using logs and one is using the graphing approach. So I'm just going to use the graphing approach first of all, because most of you have a graphing calculator. So I'm just going to set up a graphing package where I'm just going to graph 2 to the x, and I'm going to equate it to 128 and find the intersection. So let's go ahead and do that now. Okay, so there's the graph of 2 to the x, and we want to equate that to 128. So I can just bring up the command bar again and put 128, enter. Now we can't see it because it's off the page, so I'm going to double click that and just make that something a little bit larger, so we can just put 140 in. And there we go, we can see it on the right hand side. So menu, analyze graph, and intersection. So let's find the intersection there, and we can see that if x is 7, then we get 128. So in the context of our question, that is n. N would have to be 7 for this to be true. Now the other approach would be to use logs. You could just say that log of 128 is equal to log of 2 to the n, and what happens in laws of logs, so you can bring the n down to the front here. So you say n log 2 is equal to log 128, and then you just simply divide both sides by log 2. So we've got log 128 over log 2, and you will get the same result. So n will come out to be 7. Remember, it doesn't actually matter which base you put log 2. This is just standard. This is just base 10, okay? But it would work for any base, actually. So n is 7. Okay, question 3. So a geometric sequence has partial sums. S1 is 3 and S2 is 4. So basically what that means then is the sum of the first term is equal to 3. That implies then that the first term is actually just 3 itself. If the sum of the first two terms comes to 4, that would imply that the second term must be equal to 1. So it's just a little bit of a strange way of them writing it, but it's seeing if you understand that notation S. So part A is calculate the first term, or state the first term. We've just done that U1 is equal to 3. B is calculate the common ratio R. Well, when we take one term and divide it by the previous term, that is our R value. So in this case, we're going to have 1 divided by 3, which is R. So our common ratio R is actually just 1/3. Calculate the fifth term of the sequence. So let's go ahead and use the standard. UN is equal to U1 RT n minus 1. That was in my geometric sequence video. You can click the tab above or look at the link in the description. As we know the first term is 3, we can put that in. We're trying to find U5, which is the fifth term. So therefore R being 1/3 can go in here. And 5, remember this is n minus 1, so 5 minus 1 is 4. And if I just calculate that now, I get 1/27 as an exact value. And I'll just leave that as that value there. So part D, find the value of S5. So S5, I'll just draw a line down here. We're going to use this formula on the right-hand side. So ds5 is the sum of the first 5 terms. So as we now have the first term equaling 3, 1 minus, and this is 1/3, so I'm going to put 1/3 in brackets here, to the power of 5, close brackets, and that is all divided by 1 minus r, so it'll be 1 minus 1/3. Easiest way is just punch all of that into the calculator, and I get 121/27 as an exact value. So that is the end of question 3. Question 4. So we're going to look at this sigma notation again. So it says evaluate these geometric series. So what we've got to remember is that this means the sum of, right? And this can appear in a arithmetic sequence problem or a geometric sequence problem. So this one here is if we substitute this value 1 in for k, that will give us the first term of the sequence if we calculate the whole thing. Then we're going to plug 2 in, and then 3, then 4, and so on until we reach the value at the top of this sigma, which is 10. So let's just generate the sequence to begin with so we can see what's happening. So u1 is plugging, remember k is equal to 1 into the following here. So we're going to have u1 is equal to 3 times, now 2 to the power of 1 minus 1 will be 0. Now anything to the power of 0 is 1, so that means the first term is just simply 3. Let's go ahead and find the second term of this sequence. So we plug 2 in for k, and that will be 2 minus 1, which is 1. So we're going to get 3 to the power of 3 times 2 to the power of 1, so that's going to just be 6. And even from those first 2 terms, I can see what r is going to be, but we'll just do one more just in case, so u3, and we're going to plug 3 in for k now, so we'll get 3 times, and that'll be 2 squared. You can see the pattern, so that's going to be 3 times 4, and that'll be 12. And we can see straight away that the common ratio is 2. The giveaway for that is this 2 here. But if you didn't know, you can just say second term divided by the first term is going to be 6 divided by 3, and we get 2. Remember, that's our r value. So that is enough information to be able to plug into the formula. So we've got the sum of 10 terms is equal to the first term, which is 3, open brackets, 1 minus the r to the power of 10, close brackets, 1 minus 2 equals, and I'll just put that into my calculator now, 3069. And that is the end of that style of question. Okay, on to our final question here, 5. And this is the part where we're going to look at an infinite geometric sequence. So we can see on A, this sequence is going 16, 8, 4, 2, 1. If they put more terms down, then that would be 0.5, then 0.25. I can see straight away that the common ratio r is in fact half, right? So remember, u2 divided by u1 is going to be 8/16, which is a half, right? And this is our r value. So that's going to be important because if it wasn't converging towards, in this case, it's going to converge towards 0, we can't really sum the entire sequence up, because if it diverges away, then it will be, the sum of this sequence will be infinity. But because it's converging towards a value which is essentially 0, then we can actually sum up all the terms together. So we're going to say the sum to infinity, or the sum of the entire sequence, is just simply the first term, which is 16, over 1 minus a half. Remember, that's the r value, and that is going to be 16 over a half, which is 32. So very quickly we can see that the sum of all the terms of this geometric sequence are going to add up to 32. So let's go ahead and look at B now. So we've got 9, and then I just want you to think of this as like, okay, so we're going to say that this is term 2 minus 6, and then we've got 4, and then we've got minus 8/3. So what they're doing here is when it's alternating signs, when you're summing this up, you've got to think of it as though you're adding, then minus 6, and then you're adding 4, and then you're adding negative, right? So that's why it looks a little bit different. So you are still summing the entire sequence up. But actually, that's quite important when you're finding r, because r is u2 over u1, so there'd be minus 6/9, which is minus 2/3. So that is our r value. So our is a negative and it is a fraction, 2 over 3. So let's go ahead and plug all of that into this formula now, which is S equals A over 1 minus R. So the sum to infinity is equal to A over 1 minus R, and A in this case is 9, and 1 minus R will be 1 minus, so it'll be plus 2 over 3. And if we just plug that into our calculator, or we can do it manually, we get 27 over 5 as an exact value. Okay, thanks for watching. So, geometric series. Do you find these questions difficult? Would you like me to go through more examples? Let me know in the comments below. Don't forget to like and subscribe to the channel, and I'll see you next time.